good afternoon, good evening, depend on where you are watching me from. In this video, we'll be talking about Laplace transform. We are going to solve one example. Look at it here. Prove the second derivative property of the Laplace transform of Laplace of y prime prime equals to s square y of s minus sy naught minus y prime naught. As simple as ABC, but you are going to do me one favor. You help me do this. Please make sure you subscribe to my YouTube channel, share it, like it, comment on it. If you have any challenge, drop it on the comment section so that we are going to look at it together. We are all learning. But believe you me, I don't think after watching this video you will find it difficult to understand problems of this kind. Make sure you follow me. Thank you and God bless you. Not only that, I have a channel, website. Go to Google, click on this word, Remjock Maths. It will do you good. Remjock Maths. In case you are one of the engineering students finding mathematics difficult, visit this site. It's going to help you up your mathematical life. Thank you and God bless you. But make sure you share it to somebody. Share this website too. Thank you and God bless you. Okay, now we want to look at this problem. I've told you that it's not a big deal. It is not a big deal. Mathematics is everyday practice. Not that you just learn mathematics and you learn mathematics today, you wait till exam time. It's going to disgrace you. That is mathematics for you. Nobody was born to study mathematics. It's just all about a personal effort. It's okay. But with the life of mathematics is always beautiful with Mr. OSI. So I will always advise you to follow me. It's okay. Let's look at this problem. Before we consider this problem, let's go back to this advanced calculus. Go back to our elementary calculus. If you don't know elementary calculus, you always find it difficult to solve problems on advanced calculus. You know that if we have functions of this form, we call them definite integrals. Two of us. These are definite integrals, isn't it? Okay. So why? Because they have lower and upper limits. We call this lower limits and we call this an upper limit. Take note. Okay. So if you don't have the knowledge of this, you always find it difficult to solve Laplace properties. But for the sake of millions and other set of people, let me just revise quickly on this so that we go into, because this is what we are going to use. Now, this is an integral a to b dx. If you integrate dx, it will always give you x a to b. So this means that subtract this upper limit from this lower limit. How? Anywhere you see x, you substitute in b minus a. That is the meaning, and this is the answer. Is it difficult? So we'll be using this. Okay, let us have another example again. This is 1, 2. Integral a to b x dx. This is equals to, if we integrate x dx, we are going to have x raised to the power of 1 plus 1 all over 1 plus 1 integral a to b. I know some of you you are kind of surprised and confused that why is this man not adding the constant? Yes, I've told you that these are definite integrals because they have limits. So you are not supposed to write plus a or any constant. It's because of this limit. It is only in indefinite integrals that you integrate to obtain constant. These ones you integrate to obtain values, and these are the values. So this is the same thing as x raised to the powers of 2 all over 2 integral a to b. Mind you, you are not going to rewrite this integral this way because you have already differentiated. You just write it straight a to what? B. Amen? So we are going to do the same thing here. We are just going to substitute the lower limit from the upper limit. That is b all over 2. Note that x is square minus a square all over 2. This is the answer. Or, since 1 all over 2 is common, 1 all over 2, open brackets, b square minus a square. Is it difficult? So this is how to integrate definite integrals. So, and this is what we'll be using all through. Then this proof that I want to prove, you must have idea on integration by parts. It will help you. Thank you and God bless you. Make sure, don't forget to subscribe and share. Okay, so now let's look at this problem. Laplace, let us show that Laplace of y prime prime, Laplace of y prime prime is equals to s y of s minus s y of 0 or y naught, y prime of 0 or y prime naught. Okay, it's simple as ABC. What you need to do is, if we are to show, recall the formula for Laplace transform. You know, Laplace transform is given as f of Laplace of f of t is equals to integral 0 to what? Infinity exponential minus st f of t dt. Amen? Okay? Do you agree with me? So if you have this formula, you are done with everything. Please just listen to me. I hope I'm not rushing you. Okay. So now what we need to do here is, now here is in some textbooks you may see it this way. Here, what do you have here? Y prime prime, isn't it? So now your y prime prime is your f of t. So your y prime prime is equals to integral 0 to infinity exponential minus st. Instead of f of t, we write y prime prime dt. Is that clear? It's simple as ABC. You know, in some textbooks, or you may come across, show that Laplace of d square y all over the x, the t square. The t square is equals to this thing. It means this and this, they are the same thing. Is that clear? This and this, they are the same thing. So please take note. Do you understand? Take note. Okay. So if you come across, if you are asked to show in this form, you can transform it this way and this, or you leave it like this and continue. It's okay. So now, what we need to do here first, we are going to integrate this function. But look at this function. You cannot just integrate it as it is, true or false. Why? Because we have two functions here, so we need to use what is called integration by part. So you now write using by parts or integration by parts. They are all the same thing. That is, the formula is u dv is equals to uv minus integral v du. So look at it here. Look at it here. This is one function, this one is another function. So first, this is u, this is the v. So you don't need a prophet to tell you. Look at how it is in the integral. So you now first write let u be equals to exponential minus st, and the v be equals to y prime prime dt. Is that clear? So if you differentiate this with respect to t, it means our du all over dt is going to give us minus s exponential minus st. Yes. Then your du will now be equals to minus s exponential minus st dt. Please take note. Then let us look at this one again. The v equals to this. We are going to integrate both sides. If we integrate the v equals to y prime prime, it means this is the same thing as if we integrate y prime prime dt. This will going to give us v. If you integrate the v, it's going to give you v. Then if you integrate y prime prime dt, it's going to give you y prime. Take note. So now at this point we are going to substitute it into the integration by parts formula. So that is, this is equals to, do you agree with me? What is your ordinary u? We've gotten our ordinary u as this and our ordinary v as this, true or false? So our ordinary u is this. So here will now be exponential minus st. Our ordinary v is y prime. Mind you, here we have integral 0 to infinity. So integral 0 to infinity minus the formula integral, what is running from 0 to infinity. Then what is your ordinary v? Ordinary v is y prime. Then your du is minus s exponential minus st. So minus s exponential minus st y prime dt. True or false? Okay. So now we are going to substitute in here. We will substitute in here. If you can see what I am saying, if we substitute our, let's do it this way, that is lower limit, you subtract lower limit from the upper limit, infinity, we have it here, exponential minus s, anywhere you see s, t, you put infinity, then y prime, amen, okay, so if you can see what I am saying, then, okay, okay, then here we are going to write, we are going to minus exponential minus s0 y prime, amen. Okay, y prime, sorry, I think we are supposed to have y prime of t here. Let's make it y prime of t, so that y prime of t, then our y prime of t. So here, instead of this, we are going to write 0. Is that clear? And this one too is y prime of t. Okay. Y prime of t minus. It's okay. So note that continuous. This minus times this is going to give us plus integral 0 to infinity s exponential minus s y prime of t dt. Let's put y prime of t. Okay. Okay. So if you agree with me, so all of this will be 0. Why? Because of the infinity. Is that clear? Then here will be 1, isn't it? So the whole thing will now turn to, here will be 0, here will be 1 times y prime of 0. It's going to give us minus. Note that we have minus y prime of 0. Do you agree with me? Then plus integral 0 to infinity s exponential minus st y prime of t dt. Is okay. So if you can see what I am saying, look at these integrals. We have a constant s here. So here will now be minus y prime plus to bring s, factor s outside, factor it out, exponential minus st y prime of t. Is okay. So now at this point, what we need to do here is we are still going to what? We're still going to integrate this function. We'll still integrate this function using the same approach. So if we are to integrate this function again, it means we are going to still use, we'll use by part again. Okay? So now we now write to obtain, mind you, s is constant here, to obtain exponential, so integral 0 to infinity exponential minus t y prime of t dt. What we need to do here is you write applying integration by parts. So if we apply integration by parts, that is integral u dv is equals to uv minus integral v du. Do you agree with me? So so what we need to do here is to integrate this. We now say let as usual u be equals to exponential minus st and the y prime of t dt, and the v be equals to y prime of t dt. Is okay. So we are going to differentiate this and we integrate this one. Sorry, the v. Sorry, this is the v. Okay. So if we differentiate this with respect to t, we'll have minus s exponential minus s. Then our du is going to give us what? Minus s. We cross multiply minus s dt. Do you agree with me? Then integrate this idiot. If we integrate the v equals to this, we are going to have v equals to y of t, that this is what you are going to have. As if you integrate y prime, you are going to have y. So, okay, so do you agree with me? Can I clean this part? So now we are going to substitute in to the formula. Let us substitute in, but mind you, there is a constant here plus this and this. So we are going to write it this way: minus y prime of 0, amen. Then plus s is constant, so s will multiply any answer you are going to have. S open bracket. Let's recall our integration by parts here. So u v. So our ordinary u is exponential minus st. Then ordinary v is y of t, amen, running from 0 to infinity. Here, sorry, I'm supposed to, since here is t, we are using infinity. Here is supposed to be infinity, like this place, because anywhere we see t. So take note. Sorry. Okay, so now minus integral 0 to what? Infinity. Then your ordinary v is this idiot. Then your du is this, minus s exponential minus st dt. So you write minus s exponential minus st dt, right? Then why this is y of t dt, isn't it? Okay? So far so good. This is equals to minus y prime of 0 plus s. Let's substitute in the way we do here. So anywhere we see t, we substitute in the infinity sign, y of t minus anywhere we see s, we substitute in 0 of 0, then y of 0. So then this is a minus integral 0 to infinity. Mind you, we factor this out. So minus as minus, this is s exponential minus st y of t, amen, dt. Okay? You agree with me? Y of t dt. Okay, almost there. So now any, put the bracket here. So any result you have, you use it to multiply out this. So here will now be minus y prime naught plus s. I told you because of the infinity sign, the whole of this will be 0. Then because of 0, the whole of this will be 1. So here will be minus 1, which is minus y of 0 plus s integral 0 to what? Infinity exponential minus st y of t dt. Amen? So it's simple as ABC. Are you seeing? You see that it is not difficult. So can I clean this part? So if you can see what I am saying, let's do it this way. Mind you, put the brackets. So we multiply out. So this is minus y prime of 0. This one times this is going to give us minus s y naught. Then this one times this, we're going to give us s squared integral integral 0 to infinity exponential minus st y of t dt. So mind you, this is your f of what? F of t. Two of us, I told you before we started, I told you. So this will now become, when I clean this part, this will now become, instead of this is the same thing as, this is just like f of t. Then your f of t is equals to what? Y. Yes, instead of this, since we are talking about y. So here will now be equals to minus y prime of 0 minus sy naught, then plus s square y, that is f of y of t. So y of what? Y of t. But if t is equals to s, if we assume t to be equals to s, it implies that this is equals to minus y prime of 0 minus sy of 0, then plus s square y of s. So you can see that, look at it here. You don't need a prophet to tell you. So it implies that Laplace of y prime, it gives us this. Okay, can I clean this part? Okay, it gives us this. Okay, so it's not difficult. So we now conclude by saying, therefore, a Laplace of y prime prime is equals to this and this, they are the same thing. We write it this way, s square y of s, then minus sy of 0 minus y prime of 0. This is how to prove this kind of problem. Is it difficult? Any question? If you have any question, please drop it on the comment section so that we will look at it together. It's not difficult. Mind you, don't forget to share this video, like, and I told you that if you have any mathematical problem, go to Google and Google on this Remjoc maths. Just write Remjoc maths. Google will just give you the solutions there. Remjoc maths. Enter this. It will help you and do you good. Thank you and God bless you. Bye bye.